So we're working on A24, which is solving quadratic equations by using square roots. We've previously done notes on these, but I just want to take you back real quick. If I give you, and this is just some extra you can put on the side or just pay attention. If I give you the square root of 64, that's a perfect square. It's on my times table. It's on the diagonal. What is the square root of 64? 8. Now, change gears. What if I say what squared equals 64? And I said, hey, solve this.
Oh, -8 or 8.
Okay, we have two things. So when you go to solve, whenever you go to get rid of a square, you are going to come in and take the square root because squares and square roots cancel. And so, yes, the square root of 64 is 8. But you have to go back to this. We said what squared gives me 64. Well, 8 times 8 is 64, but what else? -8 times -8. So if we're just asking for the square root of a number, we're just looking at the positive root. But if I'm asking you what squared, if the original problem was x squared equals 64, that's when you have to consider the positive and negative, and we always want to use our parentheses in the calculator to test that. All right, now, what if I give you something like the square root of 24? Is 24 on my list? It's not a perfect square. If I type 24, the square root of 24 in my calculator, I don't get a pretty little number, right? Square root 24. I get this 4.898 and it goes on. So my goal is to find the biggest perfect square, and I heard someone say what?
4.
All right, now the rule is this. Actually, I'm going to write it over here. 4 times 6. Now, are there other numbers that multiply to get 24? What else multiplies to get 24? 12 and 2, but are either of those perfect squares? All right, what else multiplies to get 24? 8 and 3? Not perfect squares. So that's why we want the 4 and 6. I'm recommending you put the 4 first. I could skip right to square root of 4 times square root of 6. So if I have the square root of 24, and I break it down, the square root of 4 is 2. Keep the square root of 6. So that's it. We're done. But we're only looking at the positive. Now let me change this. If I would have told you x squared equals 24, you would do that same thing. You would come in and say, well, I need to take the square root because it's isolated and the square root. And so this time when I do it, I'm going to put my little plus or minus sign because I don't want to forget it, but I have to break 24 down. So you're going to do that same routine, but you have to consider it's plus or minus 2, keep the square root of 6. So that's the difference. If you're solving, you should get those two solutions, a positive from the root and a negative, and it's when you take the root. Okay? So let's jump into a couple of these problems. Let's look at, I'm not going to do all these, but you can't take the square root until you isolate it. So please don't come in and just try to take square roots. You need to get x by itself. So what would your first step here at number 1 be? Add 144. So you're going to show this little bit of work. And you're going to have x squared equals 144. And then how do you get rid of the square? Square root it. Now, if you tell me x equals 12, I'm going to be sending you back saying these are all wrong. Positive 12, and you can write it like that, or you can write 12 and negative 12 out.
So I wrote both. I wrote the x.
Number 2. Well, when I went to isolate it, I subtracted it, and I got x squared equals a negative 16. Are there any numbers that you're ever going to square that are going to give you a negative outcome? No. And if I try to go take the square root out of the negative, my calculator is going to tell me, oops, hold on, let me put it in there. So my calculator tells me domain error. Some of them tell you it's unreal. So this one is no real solutions. Now, a lot of times you also just see no solutions. There is a solution, but it is imaginary. Okay, let's jump to number 6. There's more stuff there, right?
God bless you.
Thanks. I didn't want to sneeze on you. All right. So what are we doing here to solve it? Add 10. Okay. Cross the line, change the sign. So we're using our old solving skills. So 81x squared equals 25. Now, I would prefer that you isolate the x squared first. So let's get rid of that 81. How do you get rid of the 81? Divide by? Okay, well, that's not pretty. I get x squared. Does 25 divide into 81 nicely?
No.
Okay, we don't want any decimals, folks. We want to keep fractions. Improper, proper, reduced fractions, we want to keep it. What's nice about this fraction, even though you don't think it's nice? They're both perfect squares, right? So when I say I need to get rid of the square, I'm going to take the square root, and I get x equals positive or negative 5/9. So we could get a fraction. All right. Now we're doing problems where it's going to break down nicely. But if you were doing like a full year Algebra 2 course and there was something stuck in the denominator, there's a lot more work to do, rationalizing denominator, etc.
You always have to put that positive and negative. Like
Yep.
Even if you get positives. Like for number 3.
For number 3, yeah, positive and negative. All right, let's flip it over. What should we do first on number 9?
-9.
Okay, so cross the line, change the sign. So 4x squared equals what?
50. Oh, wait.
No, it's 41 minus 9. Shouldn't it be 32? Okay. Now, if I wanted to, I really could take the square root because the square root of 4 is 2. Please get in the habit of isolating the x squared because a lot of times people do mess that up. You want to only take the square root of just the term that is squared. Now, 32 divided by 4, can I do it? Do I get a nice whole number? So reduce your fraction, it's 8. Okay, so I'm saying what squared gives me 8? Well, nothing I can think of, right? Not a nice number. It's not a perfect square. So we're going to come in, get x by itself. Now, so I don't forget, I'm putting my plus or minus here. But I need to break that 8 down. So what's the biggest perfect square? 2 sets of parentheses, right? Because this is under square root, you've got to keep the square root signs. What's a perfect square that divides into 8? Use your times table if it helps you. 4. 4 and 2, I agree. Please, please, please put your perfect square first so we don't mix it up. What is the square root of 4? 2. Keep the square root of 2. So in answer to the question on the other problem you asked, I need the plus or minus on every time. Now, it might be a little bit weird, but if I take this answer and I plug it into the original, 4 parentheses, oh, that's why I don't use calculators, 4 parentheses, and I type in 2 square root 2. Now, when I go to do this, I have to close the root and close what I'm multiplying by to square it, plus 9, I should get 41. Okay? If I come in and I change this with a negative sign, it's still going to square. Oh, apparently I didn't. Oh, I didn't put the negative sign in the right spot. Hold on. Let me put the negative sign in the right spot. Put my negative sign in the right spot, and I still get 41 because I'm squaring that negative number. Now, if I type in 2 square roots of 2 in the calculator, do you see that I'm going to get this decimal? 2.823 or 2.83 if you want. If I took that number and I plug it in, 4 times 2.8 squared plus 9. Do you see that I get close to 41 but not quite 41? Because I rounded it. Now, if I went and put an extra number in here, I think it rounded to 8, or let's say 2.8. I don't remember. What was the number? Was it 2.83? I don't remember. Hold on. What was 2 square roots of 2? 2.8. I'm going to do 2.828. That's what I wanted to do. All right. So if I come in here and I add the next digit, 2.8, do you see that I get even closer to 41? So if I wanted to test this, the more decimals I keep, the more place values, the closer to the number I get. The more I round it, the further away I get. Okay.
Can we do another one?
Does anybody have a specific one they would like to do?
I would like 10.
Okay. So let's look at number 10.
Probably a
It probably is. Because when I go to subtract 8, I've got 2x squared equals negative 4. Now, here's a good example. Don't do this. But I get a lot of people that come in here and they have the 2x squared equals negative 4, and they say they took the square root and they say it's 2x. Did you really take the square root of 2? So don't do that. Isolate it first, divide both sides by 2. X squared equals negative 2. A square can never equal negative, so you're right. No real solutions. You can write the null set. no real. Actually, if you want to write NRS, I would even accept that, as long as you understand that means no real solutions. This will never be true. Now, don't assume that it will never work, because if this was a -2, then the negative sign would have divided out. Okay?